Okay, you say a pen randomly selected from a box containing 7 red and 3 blue pen. Let X be equal to 1 if the selected pen is red. So actually this type of selection is considered as categorical. So your two possible outcome is either get a red or not a red. So can you please write down example 10, the possible outcome is? Okay, your success. Success means what? So in this case, you cannot say get a success. You have to say, okay, success is got a red pen. Do you get me? And because when you talk about discrete random variable, what must you do? You must be a numerical value, correct? It must be a value, am I right? It cannot be a category, am I right? So that's why now they use number 1 to represent this. You see? Because if without number, you can't count the expected outcome or whatsoever, am I right? Okay, so you have to define when you talk about Bernoulli distribution. Okay, like for example 10, correct? It is a Bernoulli distribution because there is only 2 possible outcomes. One of them is getting a red pen or not getting a red pen. So you don't say one is success and the other one is failure. If you define like that for this situation, I give you 0 marks straight away. So all your success and failure must be according to the problem. Do you get me? You have to say success is got a red pen. So we use number 1 so to represent success. In this case, getting a red pen. So failure will be what? Failure will be not getting a red pen. So you use logic 0. Sometimes we call it logic 0. All right, you learned logic before, correct? You learned logic in high school before. You say, if it's true, I give logic 1. If it's not true, false, I give logic 0. Am I right? Did you all learn that? That is also one of the reasons why you need to learn binary system in maths. Do you still remember binary system in maths? Uh-oh, it's not alien to you. Never mind. Use 0 to represent not getting a red pen. So you only draw how many times? You only draw once. You only draw once. You say a pen is randomly selected from a box containing. So now this is a box containing 7 red and 3 blue. So now I build the probability distribution table. So my variable X, take 2 values. One is 1. It means getting a red pen when I draw a pen from the box. Then not getting a red pen. Am I right? That is how I read. My 1, there is a meaning in this case. So what is the probability of getting a red pen? What is the probability of getting a red pen when I draw a pen from this box? 7/10, correct? Why 7/10? Because in the box there are 10 pens, correct? So out of the 10, 7 are red. So the chances of getting a red is 7/10. So 7/10. So not getting is 3/10. Correct? So when you talk about general binomial Bernoulli distribution, you build the table in such a way that this is your X, 1 is a yes, 0 is a no. 1 is a success. So success in the situation, I don't know what is it. You have to read the question. Okay? So failure, you have to read the question. And P represent the probability of success. And in this case, is probability of getting a red pen. So we use the small letter P to represent it. So this is probability. So P, small letter to represent the probability of success. So what is the probability of failure? Yes, 1 minus P. Why 1 minus P? Yes, because sum of the probability is 1. So that is how they get the table. Understand? Okay, so now, so for Bernoulli distribution, there are how many trials? You only draw the pen how many times? Once. Are you clear? So this is all called Bernoulli distribution. Okay? Can or not? So every question you read, you have to define what is the success, what is the failure. You don't just say success or failure. Do you get me? You have to say success is this, failure is this. So, but because we want to do the calculation, correct? So we have to use numerical value to represent the success and the failure. So how many times you draw the things, how many times you try the things? Once. You get me? Hello? Are you clear? That is called Bernoulli distribution. Because I have to make that clear, because if not, the next one I'm going to talk about will be binomial distribution. So you want me straight away go to binomial distribution or let you try the question first? Okay, you have all the time to try. Okay, you can try now. Talk about 7FA first. Okay, 7F, question 1. Okay, describe whether X is a Bernoulli random variable. Okay, a coin is tossed. X equal to 1 if the result is head. X equal to 0 if the result is tail. Is it a Bernoulli? Is it a Bernoulli distribution? Yes, the answer is a yes, because there are only 2 possible outcomes when you toss the coin. That is getting a head or not getting a head, that is getting the tail. So write down properly. Okay, let's talk about part B. 1B. Okay, 2 coins are tossed. X is the number of head tossed. Is this a Bernoulli distribution? The answer is no, because you can get 2 head one head, or none. All right. So there are 3 outcomes. So it is not a Bernoulli distribution. Clear? Okay. Let's talk about C. S is the result when the spinner alongside is spun once. So how many possible outcomes? You get number 2 or number 1, correct? So is there how many outcomes? 2. So either you get a 1 or not a 1. So there are 2 possible outcomes. So is that a Bernoulli? Yes. Okay, how about D? A person enter a store. X equal to if the person purchase something. X equal to 0 otherwise. Is it a Bernoulli? Okay, you tell me why not. Okay, you tell me why not. Okay, there are someone who say no. You tell me why not. I check the answer. Yeah, otherwise. Exchange item, don't purchase, that is considered as otherwise. Do you consider as more than 2? Okay, never mind. You can argue. You can argue. You can argue. Yeah. These are you can argue. I'm not saying you are wrong. You argue. So if I say otherwise is purchase, then can or not? If I say if you didn't purchase or you go in and exchange, that is considered as otherwise. Do you agree? Yeah, I agree. So when I put the word otherwise, that means any other thing other than purchase is considered as the outcome. So there are how many possible outcomes? Only 2. Either you purchase or you do some other thing. That is the meaning of otherwise. So it means that either you purchase something or you don't purchase something. The otherwise then means don't purchase something. So there are only 2 possible outcomes. So D is a Bernoulli. Okay, when I check the answer, okay, when I check the answer, sometimes I tell you statistics can be very misleading. When I check the answer, if you check the answer of 7F, if you have your textbook, you go to your 7F, they say C is no. They say C, no, it's not a Bernoulli. Can anyone? They say no. Why they say no? Can anyone think of why the book said no? I say yes. X is the result when the spinner alongside is spun once. Is it because it can stay in between? So it's not a 1 or not a 2? Possible? Is that the reason? Okay, maybe that is the reason. That's why they say no. Oh, okay. Possible also. So you have to be very careful. So here is not talking about success or failure. Here is talking about the score that you get. You get what I mean? the score that you get. So that is also one of the reasons. Can you please write down? So you see, sometimes you look at the question, correct? So whenever you talk about Bernoulli, it's not the number that you get. It's the situation that you get. You get what I mean? It's the situation that you get. Like for example, a person enter a store, purchase is called success. Otherwise, it's called failure. You see or not? There's no, you shouldn't. Then after that, you use a numerical value to represent it. If you write from the very beginning, it shows numerical value already. That means that is not a Bernoulli anymore. You get me? Sometimes you see Mr. also can get wrong. So be very careful. Bernoulli distribution, it must be a situation whereby there is a scenario called success. And you use numerical value 1 to represent it. Thank you. So luckily I checked. If not, I also teach you the wrong thing. Die. Okay. Do you get me? Yeah, so bear that in mind. Okay, E, a letter of alphabet is chosen at random. X equal to the number of vowels chosen. So this is definitely not a Bernoulli distribution, correct? Because they say X is the number of vowels chosen. It can be 1, it can be, do you have a word that without vowel? Oh, is there a word without vowel? Can you tell me what is it? Which word? Okay, so definitely E is no, correct? You say yes, okay, why? A letter of the alphabet is chosen at random. X equal to a number of vowels chosen. X equal to number of vowels chosen. Either is a 1 or a 0. Either you choose a vowel or not a vowel. A letter of the alphabet is chosen at random. A letter of an alphabet. I mean, I got 26 alphabet there, you just take one. Yeah. The number of vowels chosen. Okay, X is the number of vowels chosen. So when you choose, you look at it, definitely either a vowel or not a vowel, correct? Possible. So that means that is a Bernoulli. Let me check. Is it the book say yes? Seven F. Oh, the book say yes, yes, yes. So possible. That is how you interpret. It's not from a word. It's from the 26 alphabet you choose. Okay. So E is also a Bernoulli because either the letter that you choose is a vowel or not a vowel. Okay. So you have to read carefully. Okay, good. So it's not the number of vowel chosen from a word. Okay, the number. It doesn't choose a word. Okay, so X is the number because of the way they phrase it. A letter of alphabet is chosen at random. So there are 26 alphabet there. All right. So if you build the probability distribution table here. Okay, let's build. Okay, let's talk about those yes. Let's build a probability distribution. D you can't. Okay, let's do for E. So we have the probability distribution table, correct? So this is my X, either a 1. Yeah. You choose one vowel or no. All right. So what is the probability of getting a vowel out of the 26 alphabet? How many vowels? 5. 5 out of 26. And here will be 21 out of 26. All right? Am I right? You got 26 alphabet, correct? Okay, so good. Okay, so you have to read the question quite carefully. Okay, we are done with number 1. Can or not? Okay, let's go to number 2. Okay, I think just now the spinner, correct? You say lie in between. I think that is not the answer. The correct answer is because the outcome is not 1 or 0. The outcome is 2 and 1. So that is a better reason for question 1C. Why it is not a Bernoulli. So now, why I say so? Because when you go to question 2, correct? When you go to question 2, you look at consider the spinner alongside. Let X be equal to 1 if the outcome is red. You see how they define, every question when you talk about Bernoulli, okay, outcome is red. That means if you got a red, you success. If you got a white, it will be a failure. Okay, now explain why X is a Bernoulli random variable. Because there is only 2 outcomes. That is, one outcome is getting a red, and the other outcome is not getting a red, that is getting a white. All right? So there are only 2 outcomes. And the value of the outcome variable X, you use 1 and 0 to represent it. You see or not? So that is how you explain. And also the probability of getting a 1 and a 0, you add up is equal to 1. That is another reason. Do you get me? Hello? So explain why X is a Bernoulli random variable. Then find the mean of X and the standard deviation of X. So now, in order to do part B, you have to build the probability distribution table. Now you try to build it by yourself and try to do it. Okay, yes? Yeah, but give both evidence is the best. Say the sum of the probability of getting a 1 and a 0 is equal to 1. Okay, so the rest you do it by yourself if you got any. Okay, prime number and composite number. So all even numbers are not a prime number except 2. Except 2. Okay. All non-prime number are composite number except 1. And not all non-prime number are composite number except 1. Okay, so all that must remember. You see, me so forgotten in the composite number. Okay, so now I check. Very easy now for Google. That's easy. Okay, I just want to let you know, question 6 is the question whereby they can combine statistics with calculus. It happened before. They combine statistics with calculus. So how they combine statistics with calculus? If you look at the question 6. Okay, when you talk about Bernoulli, you build the probability distribution table first. X, probability 1, probability 0, 1 minus P. So they say variance. So you use the variance formula. It will be sum of xi square pi minus mean square. Am I right? So I form the formula. So it will be 1. So this will depend on P. So 1 square times P plus 0 square times 1 minus P. Take away, the mean is P, correct? The mean will be 1 times P, take away, plus 0 times 1 minus P, the whole thing squared. So that is the mean. The mean formula is this. Am I right? So all this formula you must remember. So now this will be P minus P squared. All right? So if I don't want to use calculus, so I don't want to, I can use calculus to differentiate. Actually here, okay, it will be 1 minus 2P equal to 0. So P will be equal to half. All right? So if I don't want, how can I do this? I can draw the graph. So how will this graph look like? It's a quadratic. So this is your V, this is your Px, this is your P. Okay, so when you draw this graph, one very important thing, can I just simply sketch? The answer is no, because the domain highest is 1, lowest is 0. So your graph that you sketch is very important. Until here, you must stop. If you sketch a graph beyond that, because probability cannot be more than 1. So, and here is the point. So you see, that is a maximum. When P equal to half, that would give you the maximum deviation. And we will see this in chapter 9 again. We'll see this in chapter 9 again, when we talk about largest sample size for proportion. Yeah. Okay, so that is how you do this particular question. Either you can go by calculus or you can go by graph. Can I not? So this will be the last question. Okay, done. So I want you to, since we have no homework, I want you to go back and see what is the relationship between binomial distribution and Bernoulli distribution. Okay, so tomorrow, the very first question I will ask you is that, how am I going to link binomial to Bernoulli? Or how can I use my Bernoulli concept enable me to understand binomial distribution? Got it? Okay, so done. Thank you, class.